Imagine standing in your backyard, pointing at a tree, and asking for a futuristic treehouse. Within seconds, a crew of super-fast robots zooms in and instantly snaps it together for you. In the software world, engineers call this vibe coding. Instead of typing out thousands of lines of complicated manual instructions, developers are now simply telling artificial intelligence what they want in plain English, and the AI builds the application for them. There is a catch to this magic trick. These AI builders are incredibly fast, but human language is naturally vague. When you ask for something quickly, the AI is left to guess what you actually meant. That guesswork introduces real danger. Left to their own devices, these AI builders might pull in broken, malicious materials from strangers, what developers call hallucinated software packages. Or they might accidentally dig up your prized flowers while trying to find building supplies, which in the digital world means accessing your company's sensitive internal data. To safely unleash these magical builders without causing a disaster in your yard, we have to build a secure playpen to contain them and a smart checklist to ensure they built the right thing. First, we create a magic playpen to contain the work. In enterprise software, we cannot let autonomous AI agents build directly in the live real-world environment. We put them in isolated environments, known as sandboxes. If the robots make a mistake inside this playpen, or if a piece of bad code causes a total system crash, the sandbox simply resets itself. The actual computer networks and data servers running the business remain completely unharmed. We also have to manage the tools these robots are allowed to hold. Security teams use a technique called identity and access management, relying specifically on a concept called just-in-time downscoping. Think of it as a temporary tool belt. Instead of giving the robots a master key to the whole house, which they could easily misuse, we grant them a specific digital permission that appears the exact second they need to perform a task. The moment the task is done, that permission vanishes into thin air. Even with a good playpen, we need active supervision. We introduce a layer of watchdogs, known in the industry as red, blue, and green security teams, to continuously monitor the robots while they work. Each watchdog has a specific job. The red team actively tries to trick the robots with bad instructions to test their defenses. The blue team monitors the area for any weird or unexpected behavior. And the green team instantly freezes the robots in place if a mistake happens, allowing them to fix the error safely. This chart displays the actual framework enterprise engineers use to orchestrate this security. You can see the active defense layer of watchdogs sitting right on top of the code and execution workflow, which is all supported by the strict foundational security pillars. A perfect security playpen guarantees the robots will not break your existing yard. However, it does absolutely nothing to guarantee that the treehouse they built is the one you actually wanted. So the treehouse is safely built inside the playpen. Now we have to inspect it before anyone goes inside. Old-school software testing relies on strict objective rules. It asks clear-cut yes or no questions like, are the walls solid, or does the roof keep the rain out? But vibe coding suffers from the under-specification gap. Because human prompts are vague, the AI fills in the blanks with its own logic. A robot might build a structurally perfect pirate ship, even though you really wanted a sleek spaceship. This diagram outlines how engineers measure that unstated human intent. We have to evaluate the vibe of the project across 7 different dimensions, splitting them into user-facing checks and internal checks. The user-facing side tracks what the human actually experiences. We ask, did the AI satisfy the human's unstated intent? Does the layout look visually correct on the screen? And did it use too much time and money to build it? The internal side tracks what happens behind the scenes. We ask, did the robot take a sensible, logical path to get the job done? And did the code it wrote match the neighborhood's existing style rules? In practice, engineering teams test these dimensions by blending a few methods together. They use automatic tools to scan for typos and style errors. They use secondary AI judges to score the design against a rubric, and they run browser simulations to see how the final app actually looks and behaves. This rigorous, multi-dimensional evaluation is the only reliable way to close the gap between what the robot thinks it successfully built and what the user actually meant. Zooming out from our backyard metaphor, software engineering is moving away from writing strict code and moving toward expressing broad intent. To safely operate these autonomous systems, organizations redefine trust across two distinct axes. The security axis checks if the robot stayed safely inside its boundary, working without malicious intent. The evaluation axis tells you if that work actually aligns with your original vision. Combining these safe playpens and smart checklists gives us a reliable way to turn a simple request into a working product. It allows us to move from just writing instructions to focusing on the actual ideas we want to see in the world.